Odds. All right, they give you a formula for odds, and I know it looks kind of complicated, but think about probability. We know probability is part over total. Everybody in here should know that probability is part over total. We want to think about odds in a slightly different way. When we think about odds, we're going to think about part over non-part. Okay, part over non-part, and I'm talking about the complement. So that's what this says right here. It says the probability of an event over the probability of not the event. Okay, so we're looking at two things. Either it is or it isn't. If you're looking at something, okay, that would be the top, that would be the part, and then whatever else there is would be the bottom, the non-part, all right? And so I'm saying that, and you should understand that whatever is the part plus whatever is the non-part, that's all there is. That adds up to whatever the total is. Now, I don't know if that's more confusing or less confusing, but that's the way I look at it, is part over non-part. That's odds. Number 5, the probability of rain tomorrow is 1/3. What are the odds of rain tomorrow? Okay. Now, I'm going to write more than you will probably need to write, but let's look at this from a stance of probability. The probability of rain, now remember, probability is part over total, is 1/3. Okay? So the probability is 1/3, but they want the odds of rain. And I'm telling you that's part over non-part. And so the part, we already know the part is 1. They gave it to us. Okay, if you know part over total is 1/3, then you know the part is 1. But non-part is everything else that's not included in that part. So if we know the total is 3, then what else is there? Or how many more would there be? 2, right? Okay, because these two numbers have to add up to 3. 1 plus 2 equals 3. Part plus non-part equals the total. So I know the odds of rain would be 1/2. Okay, so the odds that my horse wins are 7-2. Okay, what's the probability my horse wins? Once you get a hold of this, you'll see it and it'll be easy. Part over non-part is what they gave you, right? So if I want probability, the probability of winning has to be part over total. Well, I already know the part is 7, but what's the total? Part plus non-part equals total, so what's the total? 9. The probability is 7/9. Okay? Once you get the hang of it, it's really easy to do, but I find people really struggle with it sometimes. I don't quite understand what we're doing. Okay. The odds that a particular package will be delivered on time are 25-2. So odds of on time are 25-2. Now remember, that's part over non-part. So can you tell me the total right now? What's the total? 27, right? So we already know the total is 27. We want to find the probability of on time. So probability is part over total. Part is 25, total is 27, 25 over 27. Okay. Do you feel like you need to write all that I wrote? Probably not, right? Okay. Probably don't need to write all that, and that's fine. Find the odds against, bless you, the package being delivered on time. Okay. So this time we want the odds of not on time. Okay. The odds that it's not on time. So this time, wouldn't we want the non-part? Okay. The non-part this time is talking about not being on time. And so the odds are going to be, remember, it's part over non-part, right? 2 over what? 2 over 25, right? Not 27, because that's the total, that's probability. Probability is part over total, odds is part over non-part, or whatever we're looking at versus its complement. Okay? Number 7, if the odds in favor of a particular horse's winning a race are 5 to 7, what's the probability? You should be able to do that really quickly, because what's the total? 12, right? So do you know the probability? Okay, pretty quick. Odds of a win are 5 to 7. You know that that's part to non-part. You know that those two numbers add up to 12. So if we want to find the probability of a win, it's going to be part over total, or 5 over 12.